So we are live. This is, I think, the 9th episode of the Specter DIY Builder Call. And today we have a couple of people here. On the one hand, Tadeubas, who is going to share his work of the M3Y scanner. He entirely implemented it. Then we have Marco. Marco is probably showing us his new UI and UX improvements he made. And yeah, maybe Cryptoguide is later on joining as well. He wanted to share his draft. He already, I think, started 1 year ago, where he like edited the PCB of the normal shield. He wanted to have it in an open source firmware, like program cap and KiCad. Yeah. I think we can start with this.
Maybe before that, just asking for the completeness, Mike. You haven't prepared anything yet, so because I'm asking, so just for the completeness.
Yeah. I remember. I
maybe
did
next
some
week.
research. I did some research on using AI for upgrading the LVGL, but didn't have any success that could satisfy me. So to me, it's still too early to use it in production. So basically, even if I supply all the LVGL docs as is, the performance is nearly the same as without no context. So I think it can work, but it demands more focused approach, like converting these docs into JSON format into vector database that will be understood by LLM, so it can use it efficiently. Or possibly I should supply both the old version of LVGL and the new version, so it could understand the difference and produce the meaningful code for upgrading.
Yeah, so maybe we can dive a little bit deeper next week. I would love to do that. So I'm currently
yeah, but if possible, I'd like not to promise exact date, but if I get any meaningful result, I would be happy to share.
Yeah, exactly. Cool. Okay, yeah, Schnuartz, go ahead.
Yeah, I think now we can have a look at the PR from Tadeubas about the M3Y scanner. I already tested it.
There is another PR that is just small changes for the build process. If you want to start by this one first, it's complete, because the M3Y it's not complete yet, you know.
What you said? So what is complete or what's not complete?
There's two PRs. One for build process changes, small changes, and another PR for the M3Y scanner.
And they have some dependencies. So one is dependent on the other?
No.
I guess? No?
No.
Okay.
Just one is complete. We can start because it can be merged. But the other one, it's not ready to merge yet.
Here. Add support for selecting and combining build actions.
Yeah. And that is, I remember, I approved it, right? So, and we can merge that, right? The approved one. That's the number 333.
Maybe one of you can share your screen and we can have like a look here.
Yes, let me share the screen. I can then quickly explain as well.
I made all the changes that Schnuartz, suggested by AI and all the stuff. And I think it's ready to be merged.
Yeah. Yeah, genau. Yeah, so this is just for the one for our watchers who are looking here. So there's the build firmware shell file, which is leveraging Docker in order to build the firmware. And one of the issues is that it was not parameterizable. So now it's parameterized, so you can do different things with it on the one hand side. The other thing is that if you use Docker, there's also or there's often an issue with access with GID and UIDs in the machine, and this is tidied up somewhere. I can't find that right now where it is, but this is more or less the content of this
Yeah,
PR.
At
right?
the end of the file, you have all the commands. Yeah. So
yeah, exactly. Yeah.
So
yes.
I just pick up everything that already was executing. So, but it was in sequence. You cannot choose what to execute, what to not execute. And sometimes you want just to test something with the node bootloader version to speed up things. And so I separated them. To run easily, and created another one called fixed ownership, because when you run with Docker will run in sudo mode and will change the folder permissions to root.
Exactly. Yes, that's very helpful, because that is something which I more than often did manually somehow. Yeah, very good.
It did not change nothing, but only give options to execute small parts.
Well, but that is
yes,
a fixed ownership is always called, right? So usually, or at least for the all and the release, right? So if you run individually, then it's not called. Yeah, for sure. Yes.
That's
great.
Was the only change. The only change was this part. The rest, I only changed maybe something, I don't know, something by a type or something like that. It's the same. You can check it's the same command.
Great. Very good. So I tested it already. Copilot did some recommendations of changes. Tadeubas already implemented them. So that is ready to be merged. So I merged now. Great. And now we come to the awesome, famous, valuable new PR, which is even how do we call it? Schnuartz.
The bounty. Yeah, we had a bounty on it for $610.
Yes, yes. And it's one file change. I haven't looked at it at all, right? Yeah, but that's it. That's awesome. Yeah, if that works, wow, it's pretty much.
Yes,
I don't know.
That's a lot of code.
It's not perfect yet, because it doesn't work with ShareBoard, and it has some issues with the animated QR codes. For now, I checked, but what is interesting is that even the old scanner, GM65, it had some issues with big QR codes with more than 2000, I think, chars. If you use this QR code, it's version 27 with a little more than 2000 chars. It would broke the current firmware also for GM65.
Great.
Yeah, great.
Great work.
This is absolute awesome news. And yeah.
And what does
looking forward?
The change basically was one line change for M3Y Scanner, because we had a chunk timeout, and the scanner will take longer than GM65 to reply, and it was returning the response chopped. If the QR code was small, you would get all the response from the scanner on the timeout that is set, that is half a second. But if it was bigger, it was not enough for M3Y Scanner to give you the response. So it would do half of the response, something like that. And the code now checks if it got an end of line. If we don't receive this end of line, it waits again another chunk timeout, and get again the data from the scanner. And it has also raised an exception if it is too big QR code. I think I have doubled the 2000 chars for 4000, but as it is too hard to scan such a QR code, I think it's fine.
Yeah, maybe it would be great to have a little bit description of what the problems were, and a more how they were fixed. Yeah, and it's maybe Copilot already figures that out, and we can just copy and paste it or something like that. Sometimes it's awesome what they can achieve. So that would be great. Yeah, but other than that, yeah, this is a great Christmas gift, and there are some days until Christmas. Or how do you think how long it will take you to fix the remaining bugs?
Just a few days, I think, because I've changed the mode of the scanner from burst to command or trigger mode, and it started to give some issues. So I think it's just tweaking a bit. But on the Shield board, it already works with the light, with the turning on, off, the aim, the light, and the beep. But with the WaveShare board, it still don't work. So I think it's just little details. It's all implemented into separated functions to treat the GM65 or the M3Y scanner, or an unknown scanner will be treated like a GM65 for now.
Mm-hmm. Okay. And one question about the not working wave share adapter. So you're using the Shield like a wave share adapter, and you use the USB mini port at the bottom simply like a wave share. Is it the very same? Is it?
No, I don't know exactly how the Shield board behaves, but it is different from the WaveShare board when connected to the Disco board.
I'm just asking from a development point of view. So,
yes.
So because I thought you need to fiddle around with small cables and things like that, but you basically you use it like the WaveShare board. You just plug in the USB cable at the bottom of the shield, or how could you maybe you can also create a photo of
yes,
or show it to the camera.
That's why I've created PR for the build process, because I was building the firmware and Schnuartz, sorry, he saw that I even jumped the pin code to get testing faster into the board. So I was compiling and executing the board, but I was using the scanner on the shield lit. So it worked. And later I tested with the waveshare board and saw that it was not good. And then I realized that that it was not working for the animated QR codes too. Because when I changed the mode of the scanner, it read one QR and stops. So maybe it's just to return the old mode or give another code to the scanner to continue scanning, no? Because it's an animated QR code.
I'm asking because there is that tool from
yes. I've used your branch from this tool.
Yeah.
In order to I just connected into the wave share, and I'll show here. Using this one.
That's what I want to know. Yeah. So okay. So you connect this guy here to the board, right?
Yeah, to the
shield.
No,
to the wave share.
Yeah, on the computer. On the computer, I was using the wave share board.
Yeah.
Plug it to the scanner, plug in this port, USB mini.
Yeah.
And the board, it was on 3.3 volts.
And then it worked, or then it doesn't work? Because you said it doesn't work the wave share.
No,
right?
in the computer it works. But when I saw that the commands worked on the computer, I started to use only the shield and the disco board.
And there, and how do you cable it there? If you
yeah, just using the shield.
Yeah.
And I pasted some print commands on the code and was debugging that way.
But how do you connect the shield to the computer?
Yeah. So I was using that's the disco board and at the micro USB. So I've already commented this on the README file on the build process on the Docker one, the reproducible build. I commented out that if you want to test faster, connect a cable, micro USB cable and a mini USB cable. You'll be able to flash, and then if the jumper is on USB, you can connect via terminal to the board.
So REPL to discovery board, and then you are using Python commands in order to test manually the scanner, right?
Yeah, I didn't use Python commands. It was easier to, because if I stop the program running on the board, we don't have global variables to be assessed on the MicroPython. So it just creates an object and then starts using everything local. So if you stop the execution on terminal, you cannot get back to the state that you were working on the Specter code. No, I would have some trouble managing this manually. So I just flashed the new firmware with prints. little changes and check the terminal.
Yeah, okay. Okay. Understood.
And
Yeah.
again.
Thank you. That
until
was
it
helpful.
worked.
Yes. Yeah, it was probably, how many times did you do it?
Wow.
Approximately. You haven't counted, I guess.
No,
Okay.
too many. But the change simple change, because I have never done this before. But for the people who implemented the QR scanner, it was right away to get what was happening. It is literally one line change. The first version that worked was one line change, just to check if the scanner returned at the end of line or not. If not, scan again. It already scanned, but the data was in internal buffer, something like that. You just ask the data again after some time, and it gives the data.
Neunert left. He's back now. You are still muted, Neunert.
Sorry, fat finger. Too many tabs open, and then yeah. Okay. Thank you. Yeah. Do we have any more questions for that, or? It's only one commit. I thought, yeah, okay. Good. Yeah, do we have any more questions from anyone regarding that? Schnuartz, when do we send the funds?
From my point of view, we can already send the funds. But if you want, you can also like implement the wave share and then receive the funds.
I prefer to complete the merge when we merge the software into the official firmware. So I will be happy to receive the grant, but not before.
Great.
Okay, then I think if there aren't no, like I said, I tested everything. It worked very good from what I tested. I can see the part, the M3Y scanner, and the new version from Tadeubas, and it worked very, very good, I think. Also fixed the GM65 scanner for some. Tadeubas said that there are still problems for the animated QR codes. And honestly, I didn't found any problems yet. So I tested a couple of animated QR codes. Maybe I need to do like bigger transactions. But like most animated QR codes should also work. Maybe I'm not sure where there are issues. Yeah. So then I think we can move to the next topic. I think Marco is now, and you can maybe share what you did since the last thing. And Cryptoguide wrote he's going to join soon. So I think Marco can start.
All right, should be quite quick. So you can see my desktop, I guess. All right.
Yes.
So this is the updated version of the GUI. I made some changes to shaping. This is not so important, I think. The main feature that's added is now you can change actually the language. So now you can click on either on the icon on top of in the status bar, or you can also find it in the devices menu. There's select language. And either way, you will end up with a quick menu to see which languages are available. and select which one, or you can, this is currently just a dummy, it's not working yet, but also you should have the option to load a new language, for example, if you have an SD card inserted or something. And if we switch to German, for example, this is the one language which I added because it was quick to do and I know it. And you can see it immediately switches to the other language. And we can just switch back and it's working. I had a little bit of hassle with the umlauts, but this was also fixed. And structurally, it's quite nice and it's quite easy. It's just to add another language, you just have to provide one JSON file. So English is the default language. In the English file, you just see what the names of the strings are that you should give, and they're given in English. In any other language file, you will see also the English reference, just to make it easier for somebody to translate, that you know what am I actually translating, because just the name of the string might not always be the best for the translator. So I asked to have always the English reference included, and then you just add in which what you want to translate it with. And then you just put the file in the right folder under internationalization, and in startup, the GUI will check for all the files that are in here. And if you have the proper naming convention, so you need to be called Specter UI, then 2 letters for the language and a JSON, and then it will be made available. And during loading, also the GUI will check if all the fields from the English reference are available. And if something is missing, it will just fill it in with the English reference, so that you don't have runtime errors in that case, if something is not translated properly yet. And even the AI actually also provided a very nice README file in here, how to do it, which explains how everything is working, and even tells you how you can contribute, so fork the repository, where to look at, and then create the pull request. So quite simple, quite nice. And under the hood, it's quite simple. It's just everywhere where there was previously just a string that was shown to the user, we now have a call to a dictionary called T. That seems to be some standard technique. So I've never done this before, but I just asked the AI to do it, and they told me this is how you do it. And this is just a big dictionary where for every string, then find the proper, the actual string that you want to show. Quite simple. And since we don't have a lot of memory on the devices, as I understand, I made sure that at runtime always only one dictionary is really loaded. The rest can be on some file system. Only in the load process, because if there are some gaps, we need to fill them in with the English reference, and we need to have the English reference to know which field we expect. Only during that load time, and when you change the language, only then you need to have, for a short amount of time, 2 of these dictionaries in memory. Otherwise, you only have always one to keep the footprint quite small.
Is that something, Mike, which can be? Do we have a rule of thumb, or is it something we need to test? How much we can push on the board? How much memory we have? Or it's probably difficult to say up front, right?
Yeah, it's a bit difficult to say up front, but I don't think anything impossible for the current platform.
So what I can say is currently, I mean, with the UI in the current phase, if each language file is less than 10 kilobytes right now. Of course, it will get more if we have more fields, more menus, and so on. Especially, I mean, the next 2 features which I'd like to add is one, or the next thing is Schnuartz, I think a month ago or so, you posted some comments in GitHub what you would like to change. So, for example, different size buttons depending on the context, that you try to highlight what would be the next logical move. I think that makes a lot of sense. You also wanted to cluster, I think, let's switch back to English for people to make it, the manage stuff into one icon somewhere. This, I think, also I would like to try if this really looks better, feels better, is easier. And after that, I'd like to add this introduction mode, where we say, okay, if we detect that this is a new device and it's never been started before and it doesn't have been configured, that we then offer the option to have a guided tour through the options. And this might introduce quite some text, I would ensure, because we want to explain a lot of stuff and this will require text. But otherwise, I still think that the files are going to be rather small so in the order of several kilobytes, not megabytes.
Just to give a little context, the crux use the same function, T function, to translate from the original text to the dictionary, but we use a hash function for that. We hash the text and use a number, not the text itself, to do the lookup table. So I think it's a little faster, and the strings on the English strings on the other files that use other language are not necessary for the key of the dictionary. You could hash the key to be just a number, an integer. And
I think I understand where you're going. I think, Kim, this goes a bit back to the discussion we had. If we're gonna, I mean, in the end, during development, we're gonna run Python in an interpreted way. That's for sure. But I would assume that for release software where we generate a binary, we would really try to compile the stuff. And I would assume that a compiler would optimize this stuff anyway. So, but this is something we would then, I would not optimize beforehand if we run into a problem. But good to know that this technique is available. Thank you for that hint.
But you need to check. You need to test. See if the compiler is really optimizing this, because I don't know, if you give a key that is a string, maybe it cannot optimize this. It need to check.
Yeah, we will definitely check that once we start going onto the report. Thank you for the pointing out.
Yeah, and it's also something we can optimize in hindsight after the when shit hits the fan. Because I also think it's horrible to have such a kind of a integer and don't have an idea what. So if you have something human readable, it's always nicer, but sure, then you have to somehow, decide what's more important. But I think we can kick that. We can kick that forward.
I mean, in a worst case scenario, if we need to optimize, we could do it like that. That during the build process, we write a script that you replace it, right? That in the actual source code we have a human readable. Then when you hit the build button, then it starts replacing everything. And I think we could come up with something like that in the worst case scenario.
That's true. Yes. Cool. Yeah, thank you very much. So I'm really convinced. The more I look into AI, the more I'm convinced that we sooner or later will have a firmware which is more or less created by AI. And I know this sounds scary, but you don't have to use it. You can still use the old crappy UI. That's But I think we can have an extra discussion about that. I think, for example, Polto is one of the guys who are not very in favor of that. But yeah, thank you for the update, and I'm sure this will finally get somewhere. I'm pretty sure with that. Cool. Yeah. So Cryptoguide, thank you for having some time. Probably, you also want to show something, right?
Actually, firstly, I'll just say good job, Tad, for the M3Y camera stuff. So that's good. But I'll just quickly, and Mike can chime in on any of this because he's the one who did the original work. But I'll just show you what I've got in terms of KiCad stuff for the Specter Shield. So I'll just share my screen. Just bear with me for a moment. Start screen sharing. There we go. So basically, this is I've got two things here. So the first thing I've got is back last year sometime, I actually did manage to pull the schematic files out of Circuit Maker and just dump them straight into KiCad. And it actually does import the things like the PCB, like you probably actually could get this fabricated exactly as is, and it would probably work. The main challenge with this is editing it is a bit of a challenge in that the way all of the physical parts are in this imported file, they're not kind of grouped together in any sensible way. So this will give Mike a stroke as soon as you hear exactly what's happening. But basically here, Mike, there is no relationship between the footprint in the PCB layout compared to the schematic. So it makes updating it an incredibly manual process, and relinking it all is a complete pain. So essentially everything here is just a whole bunch of polygons. Like there are, some of the parts do have a proper pad.
Low level, like Gerber's, basically.
Yeah, that's right. So there's that, and then there is the schematic as well. But the point is that I actually had a bit of a go at that and decided it was less work to actually start with the KiCad Shield Lite and actually have a look at where I might put in, a power switch or a button and the components, and actually relay it out so that all the power is on the bottom of the board and all the other stuff is on the top, so that you can actually fabricate the power part separately if you wanted to as an upgrade, or just fab both as a single board and just push the whole thing to 4 layers at the same time, just so it has a better chance of passing that. But I kind of, again, stopped because the price for the PCBs went down with KiCad, so I didn't really worry about re-implementing it. But essentially for this one, it's been mostly just adding or padding out the power from Mike's design, throwing in a USB-C socket and just doing it all with larger components. So it's one of those things where like straight converting from one electronic design software package to another ends up almost being more work than re-implementing it by hand when you actually want to edit it and make substantive changes to it. Just because, like, I'm trying to think of a simple analogy in terms of software development, but they're kind of a little bit like redoing a website from one hosting platform to another, but in such a way that all the images and assets and stuff, all the libraries don't neatly port from one to the other, because that's the problem. So KiCad has its own footprints for schematics, its own footprints for PCBs, and sort of like they all sort of link together so that the pins on, for example, a part here all match correctly the pins, on the footprint, and everything wires up. But yeah, it's not a trivial affair to jump straight from one to the other. But once you've actually done that work, then you can. So I guess what I sort of avoided it was, given that Mike was chasing the OpenSats thing and already I had assumed had access through Altium, it's easy just to leave it in Altium and just work on it there, and then any subsequent revisions would come in something new. But if that's not the case, I dropped this other file, the one that was straight out of the importer, into the Telegram chat as just as a zip file. You can throw it straight into KiCad and work with it, just for reference. You could make modifications to it and throw like something really simple like a USB-C socket. You could put that in there. It wouldn't be too hard, but trying to change the layout in any major way would be a lot of work. And again, I think it's actually easier to start with the Shield Lite in KiCad to bring the power circuit in, and then to do the PCB layout by hand in such a way that it, again, can use larger components. And I haven't actually done this. The other thing that is worth bearing in mind, and this is where stuff like AI could get into a lot of problems, is that the power circuitry in this, and Mike could share more about this, he's probably had this issue many times, is the switch mode power supply that steps the voltage up from the battery to power the thing. If you don't actually lay those things out in a very specific way in terms of the size of tracks, the orientation of components, and those sorts of things, you can introduce enormous problems with noise. So it's not like software where you can lay the code out just about any way you like. There are actual physics problems you start to run into if the layout of the PCB isn't exactly right particularly for the switch mode power supply. So again, that was why I was kind of started on it, but then just sort of didn't worry about it pursuing it too much. And again, it's the reason why the Shield light leaves the power stuff off, is that it's just easier and cheaper just to not worry about that at all.
Yeah.
So
for proper layout, you need 4 layers.
Yeah, that's right.
On
That's
2
right.
layers, switching power supply will be very noisy. There are some exceptions, but they are very hard to match.
Yeah. So I suppose part of it, and the reason why, again, I haven't shared that stuff publicly, is that it's kind of half done. And what you would basically need to do is re-implement it in KiCad if you wanted to use KiCad. And I went with KiCad from scratch just because it's an open source thing that's freely available. So even if it goes away, it should be easy to port it to something else in the future. But you still would need to produce the board, get some fabricated, and actually validate that it works. Just because it's not one of those things where you just hit import, order one off PCBWay or order 20 off PCBWay and assume they're going to be fine. Just because there might be little strange things in terms of the shapes of footprints or the shapes of pads that just aren't quite right, that you would need to fully validate again from scratch. So it's not simply a case of switch the software over and it'll be fine. It is a case of at least in my thought, it'd be a case of re-implement it. We've got the stuff there as a reference, the schematics. The re-implementation isn't super difficult. You can knock it over in a couple of days of just solid work. But then you would need to order it, wait for it to come, either assemble it by hand or get it fabbed, and then make sure that everything works the way it should. Fully revalidate it, and only then, once you're confident with it, go.
Yeah. Overall, I think it's a great idea to port it to KiCad, but it depends on whether you have capacity for this work. And if you decide to go on with it, I would also suggest cross-porting few useful features from version 1.1, like op-amp buffer for voltage measurement, so we can drop the battery gauge and just use op-amp to measure the battery voltage, because as far as I know, currently the firmware only uses this gauge as a voltage measurement, so it's not used properly anyways.
Yes, that's right. Yeah, and again, this is the other reason why I didn't really pursue the 1.1 design, is that the 1.0 design is drop-in compatible with everything in the firmware. Whereas if we're redoing the full Shield board, it would be a good time to redo several things all at once. So use the design that Mike came up with that is a simpler design, frankly, but needs firmware support in terms of the measuring the voltage of an ADC. It's good enough to be able to perhaps do things like put all the components on one side of the PCB where possible, because that just makes the fabrication costs like significantly cheaper. Obviously, you still have to solder either the smart card reader socket.
Of course, if you have only single side assembly, it would be twice as cheaper.
That's right. It means you can do it, and even if you hand solder the smart card socket or the pin header or something.
It depends of who will hand solder, because when you order hand soldering at factory, it's just writes the cost back, because hand soldering is quite expensive. It could be like $1 per part, and it adds up very quickly if you have a lot of through pins components.
That's right. But there'd also be the scope to even change the form factor slightly, and to actually put the reader socket on the underside of the board, so that the smart card would stick out the bottom, sort of similar to the.
There's actually you don't need a battery.
Or you could fit a battery. The battery could fit higher up in the board, a smaller one or something. But I was measuring it; it would probably work. But the point is, again, the reason why I stopped was that JLC PCB dropped the fab cost of the full-size Shield board anyway, so it didn't really make sense to redo a design to save $10 or $20 a piece when they'd already halved the price of fab from 2024 to 2025 for the design we had.
I understand that cost is important for some group of people, but I'm totally advise staying at 4 layers.
Oh yes,
even
definitely.
if we
4
don't
layers.
have a power supply, because it will make things a lot of simpler if we would decide to certify it.
Yeah. No, we definitely. If you want something that's going to pass CE certification, 4 layers just makes everything much easier, particularly with the power supply. But the point is that this is actually a body of work that could actually be a project. It could be something that could be an OpenSats funding thing that would take a couple of months and include firmware and.
For the OpenSats, I decided to remove any hardware from my application because of 2 reasons. First reason, I cannot prove it's necessary because we already have working hardware.
That's
and the second reason is that this idea are not settled enough. So they were quite preliminary, quite raw at the time, because we thinking about adding a DIY QR scanner or not adding. What about power? What about smart card? On which side to place it? So I decided not to include, but I think it's a good way if you can make your own application. I can share my template if you would like. Because as I understand, OpenSats are more focused to sponsor individual developers rather than organizations. So if you are going to contribute this hardware part, it's more logical choice to apply a separate application from your name.
Yeah. So I guess the main thing I would say is if Schnuartz, all you're worried about is adding a USB-C port and leaving the rest the same, you could manually by hand make the adjustments to basically this is the mini USB port here. So you could manually move pads around, or someone could manually move pads and edit polygons and add the 2 resistors you need for USB-C. There is enough room to be able to stick some resistors on here. That wouldn't be super difficult.
It's doable on the lower level, on polygon layer, but of course it's not handy.
Yeah, that's right. That's right. So you could put in a bunch of work to get it done for just this specific tweak, and then stick with the rest of the design. The rest would probably be fine, imported straight into KiCad from the files I got that I shared on Telegram, but you'd still need to fully validate it and to order one and make sure everything works.
Now, this approach sometimes done by PCB factories. When they see some polygons not compatible with their tech stack, they just cut something, reduce something, insert their logo in some extreme cases. For them, this Gerber file surgery, it's a common thing.
That's right. So again, if you're just after adding a USB-C port as a quick thing and worry about the rest later, the stuff I dropped in Telegram is probably good enough for that. And someone could use KiCad to do that. This guy on Fiverr might be able to make it work.
So I think it's a good idea for long term. So I'm totally supporting if you decide to apply to OpenSats for making this new shield based on KiCad.
Yeah, I think what I would do if I was doing it myself, and maybe this would be something I do next year, would be essentially just focus on building the power supply as a separate module, basically, on the bottom half of the board, so that it could actually be added as an upgrade to people who have one already, because people have asked me for that. And essentially, then it makes it easy because you've got a PCB layout that mostly works, that fits on half to just, hang on, let's put that on there. So essentially the red part would be the power supply and all the power bits. And the top part would
do
be
you
existing
see
light.
it be able to cut in half, or you'll just produce 2 sets of production files, one for full size and one set for reduced size?
Yeah, something like that. Because the thing is, I was looking at what you could do, Mike, to have these 2 things be a single board that could produce them both, or have one where you just cut it and then have essentially a wire that runs up to have the power come in. But anyway, the easy thing about this is it's easier to prototype because you've got less parts on the power supply board, so you don't have to validate the top half. You just leave it alone. You assume it's fine, and then you just
yeah, but you lose some PCB real estate for this cutting line and keep out.
Yeah, that's right. That's right. So it's a compromise in terms of there's less room, but I don't know. It seems like we've got enough real estate in there. I think we'll be okay. So, but yeah, that's where we're at. Anyway, are there any questions on that? Does that kind of help you to understand where we're at and why it wasn't quite as straightforward as maybe? The reason why I haven't already done it is probably the simple answer. If it was straightforward, I would have done it. So
I
think I understand it. So I can just send the Fiverr guy the files, and then he probably is able to do the USB-C for the 1.00, right?
probably like that one that I sent you. I dropped it in the Telegram group.
Yeah, I just saw this. Then I sent it.
Yeah, it was straight out of the tool that I used to convert it, but I haven't validated it. So he might be able to do the change. He might be, and if he can, the rest of the stuff, like the rest of the like pick and place spots and all the bomb and all that stuff, that would all still just work. So and as Mike said, it might be something that the fab house has, even if he gets it most of the way there. Someone like PCB Way might have no problem at all just doing a bit of surgery on it and then getting it the rest of the way. So yeah, the only problem is, again, the footprint for the USB-C port is bigger. So you do need to sort of move a bit of stuff around. To move the only thing I would say that you should say to this guy for the Fiverr, Schnuartz, is we only want a 6-pin USB-C port. We do not want a 20-pin USB-C port. It does not need all the data pins. All it needs is the 6 pins.
But also, I would advise to choose the connector with through-hole legs, because it's much more robust. If it doesn't have through-pin legs, it must be glued to the PCB. And not every factory is doing it properly, and anyways, it's not so reliable as through-pin connectors.
Yeah.
So the one with 2 legs, right? Was 6 pins and 2 legs.
Yeah, 6 pin and 2 legs that's coming through the holes.
I'll show you what I had on this one. So hang on. So what I had...
Yeah, it's simpler to find it.
So what I had was this one here. So this is the one that I have on the...
this one has 4 legs.
Yeah, so this one has 4 legs and it has 6 pins. So this is the same as the one that I have for my Raspberry Pi.
It's just for mechanical attachment.
Yeah, that's right. So they get soldered in. These 4 things on the edge get soldered in. And then the 6 pins are essentially power and then 2 for data. But the point is, these sockets are much easier to solder by hand and much less likely to end up bridging pads together. Whereas a USB-C socket normally is very dense. It's got like 20 pins on there, which, unless you're doing complicated USB-C stuff, you don't need. So this is probably the sort of one we want. If you have a look at my KiCad stuff for the Seed Signer smart card hat, this is it's
something like USB 2.0.
Yeah, it is. It's just a USB 2.
But in a USB-C format.
That's right. So you basically, this plug is nice and cheap. And again, JLC, PCB, and PCBWay both have it and have no problems fabbing it. So it's cheap, it's plentiful, and it's very forgiving to solder. So that would be, and again, if you could just move some stuff around and make it fit. Like, we're not pulling a huge amount of current, so the main thing is to make sure the resistors are in there for USB-C to work, and that the power is connected for both sets of terminals, because this is where the Seed Signer version 1 hat went wrong, is that they didn't it only worked one way when you plugged it in, and you had to, if you turned it around the other way, it wouldn't turn on because the USB-C, the guy who did the original 1.0 hadn't wired the hat correctly. Sorry, hadn't wired the socket correctly.
Yeah.
So yeah, and they went with a big 20-pin one, so it wasn't clear whether it was an issue with fabrication at first or an issue with just the design. But yeah, so that, I put it on Telegram group Schnuartz. If you send it to the Fiverr guy, he could probably make it work. And then you just order a small batch, see if it works, and if it does, then on to a winner. So
Yeah, another question. So you showed this is like another draft from you. This is not the one I'm going to share on Fiverr, right? The one you shared on with the screen.
oh yeah, the one I shared on the screen, that was the one that I sort of half done. So that was that one is not even remotely ready to be fabricated. So you can see here, this one, I haven't even done the layout properly. Like all the capacitors and stuff are all sitting over here and need to be dragged over here and put down. I just put the plugs in and an inductor, I don't think, or something. But yeah, basically this is not. I can have a look at this next year. Like, see how this fiber guy goes. If he gets it going, good. But if he doesn't, I can get this one going.
Maybe I can ask him how much he would. Maybe I'm not sure, but maybe it's interesting to see what he would charge for it.
Yeah, well, it'd be interesting to see. And the thing is though that a lot of these fab houses, if you just give them a schematic now, like JLC PCB, will actually often do a layout for you, and their pricing is probably going to be quite competitive with whatever some random person on the internet can do. And I would suspect that what you end up with from them is more likely to work. So
at least it should be good for manufacturing.
Yeah, that's right. That's actually manufacturable.
That's where a lot of beginners' design fail when they are trying to manufacture it and factory return it because of missing technology rules. That they simply complain about the space between tracks, space between components, incorrect holes, etc.
Yeah. So again, see what this fiber guy will do if he could take the KiCad file straight from Altium basically and see if it works. And if it doesn't, if he can use that, then cool. But if he can't, the question would be whether what he offers is competitive with something like JLC's PCB layout service, which is
I think JLC PCB should have some file with their capabilities and requirements.
Yeah, they do. What I'm saying is if the cost for laying out this, basically for here, you can just throw them a schematic and they can actually lay it out for you quite quickly. And the pricing, I can't remember where the pricing was, but basically they, where was it? It was a price per component or something, or price per pin actually for their thing. But anyway, all I'm saying is that it's going to be hard for any person on Fiverr to compete with a production house in China. It is basically the thing to keep in mind. But we'll see. We'll see what he can do.
I think it's worth thinking, but also depends on could they deliver the PCB file in KiCad format so we can support it later.
That's right. The problem is if they do give it to you, if a fab house gives it to you in their proprietary format, which JLC very well might, in their state,
or they may give you just Gerbers and nothing more.
Yeah. So anyway, we've got all of that in some. anyway, hopefully that clarifies why it's not as trivial as you might have hoped. Okay, I actually have to go in a few minutes. Is there anything else you need from me? I'm sorry, I can't stick around today.
So I just have one quick question. So that you have there's like also the draft that you have like two different, like you have the shield light, and then you are thinking about making like an extra board that you can connect to it, and then you have like the shield, the full shield.
Yeah.
This is like very interesting.
That would be my approach, yeah. Just because it makes the design easier to split apart and to do, and it gives an upgrade path for people who've already got it.
But this would work. So you could do this in theory, like with the shield board you're currently having, or would you need another shield light board to do this with?
I would be looking at an upgrade for existing shield lights. People who have existing
that's
shield
very
lights.
interesting. Yeah.
So it'd be just about adding, because people have asked, "Oh, can I have a lithium kit or something like that?" Is what people have asked for, which is what